Hello students, welcome back to Sir Rasayan. Today under class 11 Redox Reactions, we will find out the oxidation state of sulfur in some compounds. So first compound I am taking H2SO3. We know H2SO4 means sulfuric acid, H2SO3 is sulfurous acid. Now remember, hydrogen generally shows +1 oxidation state, but it can be -1 in metal hydride. As for example, sodium hydride or potassium hydride. Sodium, potassium all are more electropositive than hydrogen. So here it will take +1 and it will take -1. Oxygen generally shows -2 oxidation state, OS for oxidation state. But in peroxide, means this one, it is having oxidation state, overall oxidation state 2- means each oxygen is getting -1. This is the oxidation state of oxygen in peroxide. For superoxide is O2 minus, each oxygen atom is getting -1/2 oxidation state. Peroxide linkage is this one. Clear? Now another thing you have to remember, for any neutral molecule, algebraic sum of oxidation state of constituting element is 0. Now come back here in sulfurous acid. So each hydrogen is having oxidation state +1. 2 hydrogens are there, so we can write like that way, 2 into +1 plus, let oxidation state of sulfur be X here. 3 oxygen atoms are there, each oxygen is having oxidation state -2. So this sum will be 0. Therefore 2 plus x minus 6 is equal to 0. Therefore x is equal to x minus 4 is equal to 0. Therefore x is equal to +4. Now while determining oxidation state of an element, always check it should satisfy group valency. So in sulfur is in group 6b. It can have oxidation state -2 to +6. So here group valency of sulfur is satisfied, it is +4. Therefore oxidation state of sulfur is here +4. Clear? Now we will do another example. Next example is H2SO5. Its name is peroxy monosulfuric acid. Or another name is there, Carose acid. By previous method, if you do calculation of the oxidation state of sulfur, here we have to find out oxidation state of sulfur. So what we will do here, 2 into hydrogen is having +1 oxidation state. For sulfur we can consider x, and if we are considering each oxygen is having -2 oxidation state, this sum is equal to 0. Therefore if you calculate, x is equal to coming +8. As I told you, while determining oxidation state, always check it should satisfy group valency of that element. So sulfur is in group 6b. So group 6b elements can have values -2 to oxidation state values -2 to +6. But here it is coming +8. So this is not possible. Not possible. If in any oxygen containing compound, oxidation state of central element is more than its highest value, then that compound may contain peroxide linkage. Peroxide linkage means this thing. So I am writing this thing. If in any oxygen containing compound, oxidation state of central atom is more than its highest value, then that compound may contain peroxide linkage. So here we are getting oxidation state of sulfur is +8, which is not possible because its value can be -2 to maximum +6. So in that case, what you will do here, you can conclude maybe peroxide linkage is present in the molecule. Peroxide linkage means this one. Done. And what you will do here, you will write direct oxidation state. You will write directly oxidation state of sulfur is here +6. The maximum value you have to write. Now, actual structure of the Carnot acid or peroxymonosulfuric acid is this one. Sulfur, OH, here OH. See here peroxide linkage is there, H2S12345O5. Here peroxide linkage is there. Now another thing you have to remember, for covalent bond, part bond, for one covalent bond, this is covalent bond, this is covalent bond, this is covalent bond, like that way. Here two covalent bonds are there. So for covalent bond, part bond, higher electronegative atom gets -1 oxidation state and lower electronegative atom get +1 oxidation state. So here you just see here, between sulfur and oxygen, this is more electronegative. So here it will get -1, this sulfur will get +1. Here between this, here it will get +1, it will get -1. Here two bonds are there, so directly we can write +2, -2. Here also we can write +2 and oxygen -2. Here also between these two, here we can write -1, +1, and here between these two bond we can write, if it is -1, this is +1. Clear? So let me check here, -1, +1, this one. Here for this bond we are writing +1 here, -1 here. For this bond +1 here, -1 here. Now see here, sulfur is getting 1, 2, 3, 4, 5, 6. Just add all the oxidation state. 1, 2, 3, 4 plus 5, 6. Sulfur is getting +6 oxidation state. This oxygen is getting -2. This is getting -2. This one is getting -1 plus -1. So -2. And peroxide, in peroxide we know each oxygen is having -1 oxidation state, because peroxide O2 altogether it is having 2 minus. So each oxygen it is in -1 oxidation state. So all oxygens are not having same oxidation state. That's why, but here we have considered already -2. That's why we are not getting proper answer. So whenever you are not getting this answer, whatever is the value you are getting more than that, more than the group oxidation state, then you have to write it is not possible, maybe peroxide linkage is present, and the maximum oxidation state you have to write. Now for understanding purpose, I have given you the structure. In Carnot acid, actually 3 oxygen atoms are there, as I told you, which are having -2 oxidation state, but here 2 oxygen atoms are there having -1 oxidation state. If you calculate, so 2 hydrogen atoms, 2 into +1 plus sulfur is X. 3 oxygen atoms are having -2 oxidation state and 2 oxygen atoms are having -1. Each are having -1. This is altogether 0. Therefore, we can write 2 plus X minus 6 minus 2 is equal to 0. Therefore, 2 plus X minus 8 is equal to 0. Therefore, X minus 6 is equal to 0. Therefore, X is equal to plus 6. For understanding purpose, I am writing like this way, but directly you can write the maximum oxidation state for sulfur here. Another example also we will do. Next one is H2SO8. Its name is disulfuric acid. Disulfuric acid. Here also oxidation state of sulfur you have to determine. So if you do by general method, what you will get? 2 into +1 plus 2 into X. Each sulfur is having X oxidation state, and then plus 8 into -2 is equal to 0. Therefore, 2x plus 2 minus 16 is equal to 0. Therefore, 2x is equal to 14. Therefore, x is equal to plus 7. This is also not possible. So, there may be peroxide linkage. Not possible. So, your conclusion will be maybe peroxide linkage is present in the molecule. Peroxide linkage is present in the molecule. Done. So, what will be the oxidation state of each sulfur? You will write it is plus 6. Now, you see the structure to verify. From Lewis method you have to do only sulfur's oxidation state we will do here. Oxidation state of sulfur. H2S2 1, 2, 3, 4, 5, 6, 7, 8. Now here this part of the covalent bond is +1. Here it is -1. This part will be +2. Here -2. This part will be +2. Here -2. This part will be, for this bond, this part is +1 and here it is -1. Same thing will happen here also because bonding pattern it is same here. So now see sulfur, about sulfur, what is the oxidation state? 1, 2, 3, 4, 5, 6. So each sulfur is having same thing will be here +6 oxidation state. So X is equal to +6. Each sulfur is having +6 oxidation state. Hope it's clear to you. Thank you for watching.